Hi everyone, hello everyone, welcome to the Mercury Virtual. Hope you are doing good. Today I am going to continue with your procedural programming module. That is a module that we have started in the last week, and today is I think fourth or the fifth class of this module, and we are covering the three chapters. In fact, we have covered the four chapters in the last class, and today I am going to cover the next chapter, that is the chapter number 5th, also starting with the chapter number 6. So you think this is a very easy topic. Why? Because 5 chapters have already finished in the 5 classes. So without wasting our time, let's start with a new concept. Let's start with the today's topic. The last topic that we have discussed is case structure and the functions. Today I'm going to continue with your functions, the same example of function, how function will be created, how parameter will be passed, that is the functions. So but as the class said, as the prior classes, first of all let's take what we have covered in the last class. That is the quick review of the last class, content of the last class, what we have covered. In the last class we have started with chapter number 4, that is a case structure or case control structure. That is the next part. In this we have studied what is a switch case. So what is the switch case? Whenever we have a large number of alternatives out of the whenever we have a large number of alternative and we have to choose only one or two alternative, that is done by the, or that is used by the, or that is represented by the switch statement. So case control structure includes how cases will be solved or how cases will be controlled. That is a case control structure. The first topic that what we discuss is decision using the switch statement. We have discussed that whenever we are using whenever we have a multiple choices and we have to select only one choice, then we use the switch statement. This says C provides a special control statement that allows us to handle such cases effectively rather than using a series of if statement. This control instruction is in fact the topic of this chapter. At the end of the chapter we will learn go to statement. Then how to take the decision using the switch. That is a control statement that allows us to make a decision from the number of choices. That is, we have to take only one decision from a number of choices. That is known as a switch, or more correctly a switch case default. Since these keywords go together to make up the control statement. That is, these three keywords, one is switch, one is case, one is default, is used in the switch case or the switch expression or the switch case using the decisions. This is the syntax of the switch case. This is the syntax that is used. First of all, switch, there is an integer expression. This is the important part, that there is no float expression in the switch. Only the integer expression is available in the switch statement. So in switch there is a bracket, then there is a name, that is the integer expression. Then curly braces open, case constant 1. Case constant 1 means we are using the constant 1, or either we use the alphabet, either use the characters. Then case 2, do this. Do this means performing the statement or writing the statement. Then case 3, do this, that is statement. Then default. Default means if this case or the case does not matches with the input, then there is a default value. What is the default value? Do this. So this is the statement. So these are the three cases, and if the choice is not available in these cases, then it will represent it, or it will print the default value. This says the integer expression following the keyword switch is any C expression that will yield a integer value. It could be an integer like 1, 2, 3, or an expression that evaluates to an integer. The keyword case, this is a keyword case, is followed by an integer or a character constant. As I told you, in this we are able to put either character or we are able to put either constant. Do this is the line is the form of the switch statement or the valid C statement. This is the this is one important point that we have discussed, that if no match is found with any of the case statement. Only the statement following the default are executed. That is, if the choice is not available from the number of cases, then the what statement are executed? That is, the default statements are executed. This is the best example. First of all, int I equals to 2. That is, I contains 2 value. So here this is a 2. So how, or from the cursor passes to the case 2. Why case 2? Because this contains 2. So the cursor passes to the case 2. Then printf I am in case 2. That is, it is used for printing. That is, I am in case 2. So in this scenario, the second case will be sold. The second case will be used. So this is the output, I am in case 2. In the same way, there is no stoppage value. That is, there is no break used. So this will print the succeeding, means the along with the continue cases also. That is, I am in case 3 and I am in default. The output is definitely not what we expected. We expect that the third and the third line in the given output. That is, we did not expect the third and the first line. That can be used by using the break statement. So we have discussed how the break statement will be used. So in simple terms, the switch statement what we have studied is there are 3 keywords. One is switch, one is case, one is default. Switch is used for represented, or switch case is used for representing number of decision, or taken a decision when there are a multiple number of decisions available. There is a case that contains either constant or either contains the integer. That is, either takes integer or either takes characters, right? And default value means whenever there is no matching found, then the default expression, default statement will be executed. The operation of the switch is shown below in the form of a flowchart. This is the flowchart that shows the switch. First of all, case 1, case 2, case 3, case 4. There are 4 cases. If case 1 is not used, then case 2. Not used, case 3, case 4, case then there is a stop. If it is used, if yes, statement 1 will be executed, then statement 2, statement 3 and statement 4. These are the trips and traps that we have discussed in the switch case. That is, how switch will be used, what is the syntax, how switch case will be either used in the ascending order, descending order, and the default values. In this, there is I equals to 22. So here it is switch 22. So now cursor direct moves to the next case, that is a case 22, that is I am in case 22. This is what we have discussed in the last class, that is how character will be used. Whenever we use any character in the switch cases, that must be represented within a single quote. That must be represented within this one. This is known as single quotes, QUOTES. Next tip, that we can execute a number of statements for the multiple cases. These are the multiple cases and these are the statement that is used. If we do not have a default case, then the program simply follows through the entire switch and continue with the next instruction that follows the closing brace of switch. That is, if the default is not available, then the program simply follows through the entire switch. That is, it falls or it is available for the entire switch. When we check, or we can check the value of any expression in a switch, we can check any expression. This is a switch case. We can check the expression over here. That is a legal. The break statement, when used in a switch, takes a control outside the switch. Now, then we have studied about the switch versus the if-else. That is, what is the main difference between the switch case and the if-else data. So what is the main difference? There are few things that you simply cannot do with the switch. What are these things? A float expression cannot be tested using a switch. In that case, we use the if-else condition. So these are the various scenarios where a difference is that is used whenever we use the switch case and whenever we use the if-else statement. Second point says cases can never have variable expression. That is, if we use the case in the switch case, that cannot have a variable expression, that is a plus 3. Either we can use constant, either we can use the character. That is, there is no expression, there is no variable expression that is used along with the cases. Then multiple cases cannot use the same expression. That is, they do not use the same expression like case 3, case 1 plus 2. Then we have discussed about the go-to keyword. That is, what is a go-to keyword and how go-to keyword is used. That is, what is the usage of go-to keyword. In the last chapter we have studied two more statements. One is break, one is continue. In this chapter we have studied about the go-to keyword. That is not used by the programmers, frankly speaking. Why? Because that moves the cursor to the specified location, and there is no as such requirement because the program is so lengthy. So there is no requirement for sending the signal, for sending the cursor to the another place where the definition of the function is stored. No, there is no usage. Why? Because the programmer do not have a extra time to work with. So this says, in a difficult programming, it seems so to use a go-to to take the control where you want. In a difficult programming, it is not saying that it is a good programming. It is a difficult programming. In that we can use the go-to statement that passes the control that we want. That is, as per my opinion, as per my requirement, my control passes in the program. However, almost always there is more elegant way of writing the same program using if, for, while and switch. That is, the same program can be molded, can be written in the form as if in the same way, else in the same way, for in the same way, while in the same way, switch. The biggest problem with goto is that when we do use them, we can never be sure how to go to a certain point in our code. That is, where the certain code is available in our code. That is a goto. This is the example that we have discussed. In simple terms, we have discussed one example that uses the if statement. In this, there is a go to SOS. In this, the direct cursor passes to the SOS. Here we print to error is human. These are the various explanation of the example that we have discussed in the last class. This is the next example. Here there are three loops. That is the inner loop, that is the outer loop, and this is the outer loop. So this loop is under the J loop is under the I loop. That's all. This is the summary of the chapter that is that we have already discussed in the last class. Then we have started with the next topic in the last class only, that is the chapter number 5, functions and the pointers. In this we have studied what is the function. So in simple terms, when we divide the main program into multiple parts, into multiple chunks, that is known as the functions. This is says, knowingly or unknowingly, we rely on so many persons for so many things. Man is an intelligent species, but still cannot perform all of the life tasks all alone. He has to rely on the others. You may call a mechanic to fix up your bike, hire a gardener to mow your lawn, rely on a store to supply your groceries every month. That is, we divide the main task. We divide the task into multiple parts. What are the multiple parts? Put the bike to the mechanic, hire a gardener, hire a maid for the servants, rely on a store to supply the grocery every month. So, this means the home task or my personal task is divided into multiple parts. In the same way, computer program find itself in the similar situation. It cannot handle all the tasks. That is, computer programmer cannot handle all the tasks by itself. Instead, it requests other program like entities known as the function in C to get its task done. That is, it uses other programs, it uses other functions that is available in C to get the task done, to get the work done. In this chapter we study about the functions. So in simple terms, a function is a self-contained block of statement that can perform a particular task again and again. So a function is a self-contained block that is available for the, or that is used for the some kind. Every C program can be thought of a collection of these functions. That is, every C program can consist of multiple collection of functions. Suppose you have a task that is always performed exactly in the same way, say a bi-monthly servicing of your motorbike. When you want to be done, you go to the service station and say it is time, do it now. That is, you do not need to explain each and everything, that this is my bike, you have to service this bike. No, you simply go, it's a time, do this, because the concerned person is already know that you always come at the ending or always come at the bi-monthly, so that your bike will be serviced. Let us look at a simple C function that operates in much more as a mechanic. This is a simple function that is we have discussed. This is the message, this is the function calling, and this is the function definition. So here the function will be called, and here the function definition will be arrived. This is the definition of the message function. This says here main itself is a function. This is also a function, and through it we are calling the function message. That is, in this we are calling the function that is a message. What do you mean, or what we mean when we say that main calls the function message? That is, this calls the function message. We mean that the control passes to the function message. Calling means the control passes to the next function, that is a message function. The activity of the main is temporarily suspended. That is, for the time being the main function stops working, and now the cursor or the focus moves to the next function, that is a message function. The activity of main is temporarily suspended. It falls asleep while the message function wakes up and goes to work. It works when the message function runs out of the statement to execute. The control returns to the main statement. That is, when it finished the execution, then again control passes to the calling function, that is a main function. So the main function becomes a calling function, while the message becomes the called function. This is the called function, this is the calling function. This is the next example. Here there is a main function, three functions are declared, defined, the function definition is given. These are the function calling. One is Italy, one is Brazil, one is Argentina. This is the example that we have discussed. That is, first of all, the definition of Italy is considered, then Brazil definition is considered, then Argentina definition is considered. So first of all it will execute the Italy definition, then Brazil, then Argentina. So what is the output? First of all, I am in main. Why I am in main? Because this is the first line, that is, I am in main. Then I am in Italy, then I am in Brazil, then I am in Argentina. These are the few examples, these are the few conclusions that can be drawn after writing this program. This is what we have covered in the last class. So now let's start the next class, that is the today's class session. What is going to cover in the today's class? The main focus of my today's class is on the functions. That is, how function will be used in the C programming language, so that we can divide the main C program into multiple tasks. This is, as we noted earlier, that the program execution always begin with the main function. Except for this, all C functions enjoy a state of perfect equality. That is, except for this fact, every C program, every C function enjoys a state of perfect equality. That is, equal, or the equal consideration is given to the main function, to the various function that is used in the C program. No precedence, no priority, nobody's boss. That is, there is no supervisor, there is no supervising committee. One function can call another function it has already called, but it has in the meantime left temporary in order to call a third function, which will sometime later call the function that has called it. If you can understand what I mean? No. Well, let us illustrate with an example. So this says one function is calling the another function is calling the another function. There is a chain of queue, that one function calls another function again calls another function, and that contains a definition of third one. So all the functions are related with each other. So let's take an example. First of all, there is a main function. There is a line that is printed, that is printf I am main. That is, the same line will be printed on the screen. What is the same line? I am in the main. Then a next function is called, that is the Italy function is called. There is a semicolon, that is means a function calling. Whenever a semicolon is used, it moves the cursor to the definition of the Italy. This is the definition of the Italy. This is the definition of the Italy. here if I go, the cursor passes to the Italy only. If the cursor passes to the Italy, then this definition will execute. So first of all, the first line is that I am in Italy, and in Italy there is a Brazil that is used, that is the Brazil definition is used. Now the cursor passes from Brazil definition to Brazil calling to Brazil definition. In this there is I am in Brazil and there is a Argentina only. Then again the control passes to the Argentina, there is a printf that I am in Argentina. Right. Now the cursor moves to the again Argentina, that is over. Again come back to the Brazil. Now this task is also over. Then this line will be printed, that is I am back in Italy. Then again the cursor moves to the Italy. Here all the task is done. Now printf all these values, that is I am in Italy, I am in Brazil, I am in Argentina, and I am back in Italy. So for statement will execute over here only, over this point. This is the point, that is the next point. I am repeating again, till this point the for statement will execute it, that is I am in Italy, I am in Brazil, I am in Argentina, as well as next statement is that I am in back in Italy. These are the four statements that will be executing whenever we are pushing back or whenever we are going back, that is till this point, and at last this line will be printed. I am finally back in main. This is the same. I am in main, I am in Italy, I am in Brazil, I am in Argentina, I am back in Italy, and I am finally back in main. These are the statements, or this example represents how one function will be called in the another function and how another function will be called in the another function. That is, there is a chain of queue in which function is called among the each other. That is a calling of the function again and again by itself. This says here main function calls another functions, which in turn calls still other function. That is, the main uses Italy, Italy uses Brazil, Brazil uses Argentina. Trace carefully the way control passes from one function to another function. Since the compiler always begins the program execution with main statement, that is, the compiler always begin the program execution, every function in a program, that is every function that is used in a program, can be or must be called directly or indirect by main function. In other words, the main function drives another function. That is the main function, that is the most important function, that is the main, and that can be used or that can drive the another functions also. That is, it can drive the another functions also. Let us now summarize that what we have learned so far. C program is a collection of one or more functions. So this is the summary of the functions. C program is a collection of one or more function. That is, C contains more than one programs, or C contains more than one function. Every C program. A function gets called when the function name is followed by a semicolon. That is, a function is called, or function it becomes a calling function when the function name is terminated by the semicolon. Like Italy, there is a semicolon, then that function will be calling function and the definition is given over to the next place. So this is the second point, that is, a function gets called when the function name is followed by a semicolon. This is the example, that is a main Argentina, curly braces open, curly braces close. Then a function is defined when a function name is followed by a pair of braces in which one or two statements may be present. That is, a function is defined when a function name is followed. That is, this function is defined when a function name is followed. That is, if it is followed, that will be defined. This is the example. This is the definition of the function. So first of all, it is a collection of one or more functions. Then a function gets called when the function name is followed by a semicolon. Then the function definition is given. Then any function can be called from any other function. That is even main can be called from the another function. That is, we can use any function in the another function. That is, one function contains one function, another function contains another function. That is, one function called another function called another function. In the same way, the same cycle will circulate in the whole program of the C. That is, in whole C program. This is the example. There is a main, there is a message. Here in main, the message function will be called. This is the definition of the message in which the main function will be called. That is the main function. This will be called. Next part is here. A function can be called any number of times. That is, we can call a function with any number of times. With n number of times, that is, we can use any number of functions with can be called on any number of times. That is a main. There is a message. There is a message. So these are the two functions that will be used. This is the definition of the message. Why? There is one definition because the function name is same, but it is declared two times. So this will be printed two times. Why? First of all, the output of this is jewel thief. In the same way, in the next line, the output of this is jewel thief. Next point says the order in which the functions are defined in a program and the order in which they get called need not necessarily be same. That is, it need not that if message 1 is written over here, then I should write, or it is mandatory that I should write message 1 definition at first place. No, it's not mandatory. We can use any function at any time. That is, we can give definition of any function at any time. For example, this one, in this the message 1 will be declare message 1 will be called first and then message 2, but the definition is first of all of the message 2 and then message 1. So there is no hard and fast rule that the function definition must be in the sequence. No, that is not a hard and fast rule. Even though message 1 is getting called before message 2, that is, it is used, or message 1 is used before message 2. Still, message 1 has been defined after message 2. That is, it is defined after message 2. However, it is advisable to define the functions in the same order in which they are called. That is, it is advisable for the programmer to do not create any confusion among the functions. In the function definition is given in the same order in which it is defined. This makes the program easier to understand. Why? That is the same thing. That is, it increases the readability. That is, the program become easier to understand. Next part says a function can call itself. That is, a function can call itself. That is, if I am using the function that is a message function, it can call the same function again and again. That is, the function can call itself. That is a recursive function. Such a process is known as the recursion. What is recursion? When the function calls itself again and again, that is known as the recursive function, or that concept is known as the recursion. We will discuss this aspect of C program later in this chapter. That is, we will use this concept in the later or the end of the chapter. Next suggestion or the next type is that a function can be called from another function, but a function cannot be defined in another function. That is, we can declare the function, we can call the function within another function or from another function, but it cannot be defined. That is, we cannot define the same function, or we cannot define the function in other function. That is, we cannot give the explanation or definition in another function. Therefore, the following program would be wrong since Argentina is defined inside another function, that is a main function. This is not correct. Why? Main is also a function, Argentina is also a function. This is not correct, that it is or it is not advisable that the function definition is given within the another function. That is, in main this definition will be given. No, this is not possible. Next part is there are basically two types of function. One is library function, one is user defined functions. Library functions are that is predefined, that is used by the programmer, or that is used by the C programs. Example, printf, scanf. That you should also use the same. I am also using the same. Every C programmer using the same, because that is a library function. So library function that is common to everyone, that is used by the programmer in the same way what we are using, what you are using, everything is the same. That is a library function. But user defined functions are those functions that are defined by the user. That is based on the user to user how it will be or how he or she will be used. So it depends on the person to person, the name will be different, the types will be different. Either you can use int, float, double. If I am using long, double, that is a different thing. That is a user defined functions. So there are two functions. As a name advice, library functions are nothing but commonly required functions grouped together and stored in what is known as library. That is a common function, that is a commonly used function that is defined in another library, another part that is known as the library. This library of functions is present on the disk and is written for us by people who complete compilers for us. That is, it is present on the disk, the library function, and that is, it is available in the computer, it is available in the software who writes the compiler for us. Almost always a compiler comes with a library of threaded functions. The procedure of calling both types of function is exactly the same. Next topic is your why we are using the function or why use the function. That is, what are the advantages of using the function. That is the next part, that is why use the function. This says why write separate function at all, why not squeeze the entire logic into one function, that is the main function. There are two reasons why we are using the function, that is why we are dividing the main program into the sub-programs or into the different chunks. That is the main part, that is the advantages, that is what we have studied. First of all, what is the main reason? Writing functions avoid overwriting or rewriting the same code again and again. That is, we can use the same function again and again. That is a reusability. So the concept is that we can write the functions, or writing the functions avoids rewriting the same code again and again. That is, we can we are using, or we are able to rewrite the same code again and again. That is, avoids the writing the function. For example, if I am writing one program that contains 4 functions, right? That 4 functions, out of these 4 functions, one function is used by my colleague, by my boss. That is the same function, that is the same program, same code, but only one function or 2 functions, that depends on the capability. That is, 2 functions are used again and again by my colleague, by my boss, my manager. That is the main advantage. That is, it avoids rewriting the same code again and again. That is, there is no wastage of time, so we can use the same code again and again, over and over. Suppose you have a section of code in your program. That is, suppose you have a different program. Suppose you have a different section that calculates the area of a triangle. This is the example. If later in the program, that is at the later stage, you want to calculate the area of a different triangle. That is, at the later stage, you want that, your requirement is that you are able to calculate the area of a triangle or area of a different triangle. You won't like it because you are required to write the same instruction all over again. This is so boring task. Why it is so boring? Because you have to write the same program again and again, again and again. Instead, you should prefer to jump to a section of code that calculates the area. That is, you are able to do, or you are able to perform the same task again and again to perform the area. That is, you prefer to jump to a section of code that calculates the area and then jump back to the place where you left off. That is, takes the code of the area for calculating the triangle of area of a triangle and then come back to the place where you left off. This section of code is nothing but a function. So in simple terms, this paragraph says when we are using the functions, this saves our time because we can rewrite the, or we can reuse the same code again and again whenever there is a requirement. Next point says, using functions, it becomes easier to write the programs and keep track of what they are doing. That is, whenever we use functions, it becomes easier to write the programs. That is, it is become easier. Why? Because the whole program is divided into multiple parts. So it is very easier to write the program again and again and keep track of what they are doing. If the operation of a program can be divided into separate activity and each activity placed in the different function, then each could be written and checked more or less independently. That is, each program, each code could be written and checked more or less independently. Separating the code into modular function also makes the program easier to design and understand. So in this paragraph, in second point, it is says that whenever we use the function, so it is better to use the, or it is better to design and understand the concept, that is using the functions. That is, keep track of what they are doing. Next is, what is the moral of the story? That is, what is the moral? What is the usage of the story, or what is the crux of the story, that why we are using the functions? This says, don't try to cram the entire logic in one function. It is very bad style of programming. That is, don't try or don't use that you have to try the entire logic in one function. That is, you have to apply the same logic or the entire logic into one function. No. Instead, break a program into small units and write the function for each of the isolated subdivision. That is, uses the function to divide the program into different isolated subdivisions. Don't hesitate to write the functions that are called only once. That is, do not hesitate to write the functions that are called only once. What is important is that these functions perform some logically isolated tasks. That is, the functions are used to perform the logically isolated task that is used by the programmers. Now, this is the most important topic, that is how to pass the values between the function. That is, how to pass the arguments. Values are also known as the argument. That is, how to pass the values between the functions. This is, the function that we have used so far have not been flexible. We call them and they do not, and they do what they are designed to, right? Like a mechanic who always services the motorbike in exactly the same way. That is, it uses the same way as we have done in the way. Who always service the motorbike in exactly the same way, we have not able to influence the functions in the way they carry out a bike. It would be nice to have a little more control over what function do. That is, we have to control, or we have to add something, we have to initialize some new in the functions. Also change the engine oil. I'm going for a outing. It would be nice to able to tell the mechanic, also change the engine oil. I'm going for a outing. In short, now we communicate between the calling and the called function. So there are two functions. One is calling function, that is denoted by the semicolon. One is a called function, that is the definition of the function. The mechanism that is used to convey the information to the function is known as the argument. That is the mechanism or the way to convey the information. How we convey the information to the definition of the function, that can be conveyed by using the argument. So one is a concept, or one concept is argument. That is the way to communicate to the function. You have unknowingly used the argument in the printf and the scanf function. The format string and the list of variables that used inside the parentheses in these functions are argument. That is, whatever we use inside the parentheses, that are known as the arguments. The arguments are sometimes known as the parameters. This is the next another name for the argument, that is a parameter. So one is argument, one is parameter. So whenever we use or whatever we use after the name of the function, that is after inside the parenthesis, that is known as the arguments or the parameters. Consider the following program. In this program, in main, we receive the value of a, b and c through the keyboard and then output the sum of a, b and c. This is the argument, this is the function called, this is the function calling, That is, the cal sum is the function name and a, b, c are the arguments. So there are there are two concepts. One is function name, one are known as arguments of the parameter. So this is the function name, that is a cal sum. These are known as arguments of parameters. This is then output the sum of a, b and c. However, the calculation of sum is done in a different function, that is a cal sum. Cal sum is the name of the function. If sum is to be calculated in the cal sum and the values of a, b and c are received in the main, then we must pass on these values to the cal sum, and once cal sum calculates the sum, we must return from the cal sum back to the main. So in simple terms, this paragraph, or the crux of this paragraph, says we have to pass the, or we have to send the argument to the called function, as well as we have to receive the argument from the called function. So in simple terms, the calling function sends the argument to the called function. In the same way, it receives the arguments from the called function, or from the called function. That is the main task of the calling function. Now let's see. This is the main, that is the main function. Then int a, b, c, sum. That is 4 variables are used. What are the 4 variables? One is a, one is b, one is c, one is sum. Then printf enter any 3 numbers. That is enter any 3 numbers. That is the next exam. This printf will be used. Then scanf, that is used for storing in the memory. Why they are using %d? Because it is of integer type. These 3 variables are of integer type. That is a, b and c. Uses the ampersand for storing in memory, right? Then uses the function. What is the function name? That is a cal sum. So cal sum is the name of the function. And what are the arguments? What are the parameters? What are the parameters? That is a, b and c. These 3 are the parameters of the argument that is placed inside the parenthesis. This is known as parenthesis, this one and this one. This is the semicolon. Now the output of the whole function is stored in the variable that is known as sum, that is also of integer type. So you see, all the points are interrelated. First of all, the variable is declared, then print the same line, scan the same line, then uses the cal sum, that is a function name, that is a cal sum is the function name, passes the argument. What are the argument? A, b, c and a, b and c, and this output, that is the output of this function, is stored in the variable that is of sum, that is a sum variable. Then printf, that is print the value of the sum. There is a curly brace, that is closed. Now when this function will be called, cursor automatically passes to the next part. What is the next part? That is a cal sum, that is a definition of the function, that is a called function. So now this function becomes the calling function. This is the calling function in which semicolon is used. This becomes the called function in which semicolon is not used, in which the definition of the function is given, that is a cal sum. In this there are arguments, that is a, b and c. So we can change the arguments. One more point, these arguments are known as the actual argument. I am repeating again, these arguments are known as actual, A-C-T-U-A-L, that is actual arguments. And this x, y, z are known as the formal argument, F-O-R-M-A-L. So one is actual arguments, one is formal argument. So whatever we are using, or whatever argument we are using in the calling function, that is known as the actual argument. And whatever the functions, or whatever the argument we are using in the called function, that is known as the formal argument. So there are 2 types of argument in the C language, or in any programming language. One is actual arguments, one is formal argument. Then this variable will be declared, or these variables will be declared. What are the 3 variables? X, y and z. Then again one variable will be declared. These are known as global variable. Why they are known as global variable? Because it is declared outside the curly braces, that are known as global variable, and this is a local variable, that is int d. D is of integer type. Then uses the variable to calculate the sum. What is the calculation part? That is adding the values of x, y and z. That is add the three values, that is the x, y and z, and then store the three values or the output of three values into the variable, that is d. So these three will be added up and then stored into the d, that is the next part. Then there is a return. What is return? That is a d. So this is the definition of the calsum function. Here till this is the definition. I am repeating again the definition. First of all, three variable will be declared, that is x, y, z, and our local variable, that is int d. One variable is declared. Then uses the d, stores the output in the d. What is the output, or what is the output? That is x plus y plus z. That will be stored in the d. That is d. Then return the d. Whenever we return the d, the control passes to the, again come back, this is the calsum. This d output is stored in the memory. Suppose d has a value 20. This will be returned over here, and this 20 will be stored in the sum variable. That is sum contains the 20. So this is the how it works. And then next line will be used, that is print the value, that is the sum equals to 20. Now here is the output. First of all, the same line will be printed, enter any three numbers. Enter any three numbers. Users enter 10, 20 and 30. This will be stored in the memory by this one, 10, 20 and 30. Then this function will be called, that is a calsum function will be called. When this is called, calling function, then the cursor moves to the next part, that is this part. So when cursor moves to this part, this is x, y, z, that is three functions or three variables are used. Again three variables are used. Then adding up the three variables, that is 10, 20, 30, and put the output in the d. That is the next part, that is put the output in d part. This is 10, 20, 30, then put the output of 10, 20, 30, that is 60 in the d. Return the d. When you return the d, it will passes the cursor to the calsum a, b and c. So this means whenever the d will be returned, it moves the cursor, it passes the cursor to the next part, that is a calsum a, b and c, and that output, that is a 60 output, 10 plus 20 plus 30 is the 60 output is stored in the sum variable, that is in sum, and then sum will be printed. This sum will be printed. So this will sum equals to 60. There are number of things, there are number of varieties that you note about the program, about this program. What are the number of notes, or what are the number of things that you can note? The first approach is that in this program, from the function main, the values of a, b and c are passed to the function calsum by making call to the function calsum and mentioning a, b, c in the parentheses. That is, we are using the function main sum, the values of a, b, c and passed on to the function calsum. This will be passed, that is a, b and c, by making a call to a function calsum mentioning a, b, c in the parentheses. That is, a, b, c is used in the parentheses and the output is stored in the sum part. In the calsum function, these values get collected in three variables. That is, these values will be collected in this variable, that is x, y and z. That is, three variables are used. Int x, y, z. The variables a, b and c are known as the actual argument. That is, the variable that is used, that is the variable that is a, b, c are known as the actual argument. As I told you, there are two types of argument. This is known as actual argument, whereas the variable x, y and z that is used are known as the formal argument. So one is actual argument, one is formal arguments. Any number of argument can be passed to a function being called. That is, we can pass any number of argument. It may be 3, it may be 4, any type of argument and any number of arguments. However, the type, order and the number of actual argument must always be same. This is one of the most important line. That is, if we are using the 4 actual argument, then the 4 formal argument must be 4. If we are using the type int in the actual argument, then in the formal argument it must be of type int. That is the next part. So the number as well as the order are the same. That is, if we are using 4, then it is a 4. If we are using int, then it is int. So this is the next part, that is the number of things that we note about the program. Instead of using different variable names, that is x, y and z, we could have used the same variable name, that is a, b and c. But the compiler will treat them as a different variable since they are in a different function. That is, it is advisable to use the different argument. That is, if we are using ABC, then use the XYZ in the next part. That is the next one. There are two methods of declaring the formal argument. The one that we have used in our program is known as Kanigan and Ritchie, or K and R method. What is the method? Uses the cal sum XYZ, then uses int XYZ. Another method is that uses the same data type over here only. So this is the main, I think, best method. In this, first of all, this will be used, then declare the type, that is the int type. This is also same, int x, int y, int z. This is known as ANSI method and is most commonly used in these days. So either use this method, first of all the variable will be declared, then use the data type, or use the same data type and the variable, data type variable, data type variable. In the earlier programs, the moment closing braces of the call function was encountered, the control returned to the calling function. That is, this curly braces will encountered. This will be encountered. Control automatically passed to the cal sum. Here only. This is the calling function. This is the called function. Was encountered. The control passes to the return to the calling function. No separate return statement was necessary. This approach is fine if the called function is not going to return any meaningful value to the calling function. In the above program, however, we have to return the value of sum of x, y and z. Therefore, it is necessary to use the return statement. So it is necessary to use the return, that is return D. First of all, in the earlier program, there is no requirement. There is only curly braces. At the end, there is a curly brace. So there is no requirement of returning. There is no requirement that we have to return. We have simply used the closing curly brace. The cursor moves to the outer part. But here, this is very important that use the return, that is a return D, for the returning the value, that is return D. The return statement serves two purposes. What are the two purposes of the return statement? On executing the return statement, it immediately transfers the control back to the calling function. So whenever we use the return statement, it automatically, or it immediately, not automatically, it immediately transfers the control back to the calling function. That is, it immediately passes the control to the function where it started. Next, it returns the value present in the parenthesis. That is, it returns the value that is present in the parenthesis after return to the calling function. That is, it returns the values that is available in the parenthesis. That is, for example, in this example, there is a return D. This is the return. There is a return D, that is a 60, that will be passed to the this function, that is the cal sum. Here only the 60 will be passed to the this one. In the above program, the value of sum of three number is being returned. What is the output? That is the 60. Next point says there is no restriction on the number of return statement. That is, there is no restriction on the number of arguments, on the number of return statement that we are using, that may be present in a function. Also, the return statement need not always be present at the end of the called function. That is, it is not mandatory that it is available at the end of the called function. The following program illustrates the fact. There is a function that is used. There is a function that is used, that is a fun function. There is a char c, then there is a printf, enter any alphabet, then there is a scanf, that is storing the alphabet, then uses the if function, then return the ch, else return the ch plus 32. That is, we can use more than one function in the return statement. This is the return statement, that is more than one function or more than one statement is used. In this function, different return statement will be executing, depends on whether ch is capital or not. If it is capital, this will be execute. If it is small, this will be execute. Next point says, whenever the control returns from a function, some value is definitely returned. That is, whenever there is a return statement, so there is some output that is available. If a meaningful value is returned, then it should be accepted in the calling program by equating the called function to some variable. This says when the control passes, it automatically or it definitely returns the value. Next point says, all of the following are valid return statement. Return A, return 23, 12.34, simple return. So we can use either character, integer, float, as well as only return. There is no parenthesis, there is no argument. In the last statement, our garbage values is returned since we are returning not any specific value. There is no specific value, so garbage value will be returned. Note that in this case the parenthesis after return are dropped. That is, there is no parenthesis that is used. Next point says, if we want that a called function should not return any value, that my requirement is that there is no called function, there is no return type of the called function, there is no return value of the called function. In that case, we must mention by using the keyword void as shown below. This is the void display, printf, this one and this one. That is, this is the output. That is, display function does not return anything. So whenever we want that the function does not return anything, so use the word that is a void. So void display. Next point says, a function can return only one value at a time. That is, it can return only one value at a time. Therefore, these are the expression, these are the statement that is invalid statements, because these return more than one statement at the same time. That is not possible. Why? Because only one variable, either a will be returned, b will be returned, 12 will be returned, x will be returned. There is a way to get around this limitation, which would be discussed in this chapter using the concept of pointers. Next point says, if the value of formal argument is changed in the called function, the corresponding change does not take place in the calling function. That is, if we are using a equals to 30, but in this we are using b equals to 60. So there is no changes. There is no changes means the called function is as it is and the calling function is as it is. Means there is no connection between the formal argument and the actual argument. If the value change in the formal argument, that does not impact on the actual arguments. This is example, int a equals to 30, fun a. That is, first of all, a has a value 30. This function will be called, that is the fun function. Cursor directly moves to this part. Here, this is the actual argument, that is here. In this, this is the formal argument, that is b. Here a has a value 30, here b has a value 60. So both have a different values. Now print the value of b. So b has a value 60. So first of all 60 will be printed. Whenever this will be used, so the cursor return back to this one. So this line gives the output 60. Then printf the value a. Now a value will be printed that has a value 30. So this diagram or this example shows that there is a difference between the actual and the formal argument. Whenever we change the formal argument, that does not impact on the actual arguments. That is, even though the value of b is changed in fun, the value of a is same in the memory. That is, the value of a is same, it is used in the same in the memory, that is 30. That is, the b value cannot override the a's values. This means that when values are passed to a called function, the value present in actual function argument are not physically moved to the formal argument. That is, they are just the photocopy of the actual argument. That is, the value cannot pass to the formal argument. Only the photocopy version, only the Xerox copy of the arguments are passed to the formal arguments. Now, what are the scope rules of the function? That I will discuss after the break. So let's take a break and then come back starting with this topic, that is scope rule of the function. So let's take a break. Now let's start with the next topic, come back from the break. Let's start with the next topic, that is the scope rule or the scoping rule of the functions. That is, what is the rule of the function, or what is the scope rule? What is the scope? That is, scope means in the sense that till what place the argument will be used. That is the scope rule of the functions. So let's start with this topic. Look at the following program. This is the program. First of all, there is I equals to 20. That is, I has a value 20. Then displays the I. So this function returns or displays the value, that is 20. Then it will be used, that is, this function will be calling function. Here semicolon will be used. Then I can determine that this is the calling function. Whenever a semicolon will determine, this passes the cursor from this place to this place. That is, passes the cursor from this place to this one. The same function name will be used, that is display, but the argument is different. That is, here it is I, it is j, that is int j. Then there is a curly braces, that is start. Then there is a int, new variable will be declared. What is the variable or what is the value of the k? That is a 35. So this is k equals to 35. That is, k has a value 35. That is, k has a value 35. That is, k equals to 35. Then print the value of j. That is, print the value of j. First of all, j value will be printed. What is the value of j? This is 35 and the k 35. In this program, it is necessary to pass the variable of I to the function display. That is, it is mandatory to pass the variable or the value of the variable, that is I, to the function display. Will it not become automatically available to the function display? No, because by default the scope of the variable is local to the function only. That is, this value cannot pass automatically to this place. Why? Because that scope is already available to that one only. So we have to define the variable, we have to declare the value again and again whenever we use the scope and whenever we use the block of the statements. The presence of I is known only to the function main and not to any other function. Similarly, the variable k is local to the function display, and hence it is not available to main function. That is, the k is also available to the function display only. This is to the display only, and that cannot be available for the main function. And that is why to use or that is why to make the value of I available to display, we have to explicitly passes to the display. Likewise, if we meant k to be available to main, we will have to return it to the main function using the return statement. In general, we can say that the scope of the variable is local to the function in which it is defined. So in the simple terms, it is defining the scope. What is the define or what is the scope rule? What is the rule that is available? That it is available at the inner state, that is the inner block. If the function will be used in the inner block, that is available to that block only, well, that is local to that block only. So if I am writing int I equals to 20, that 20 will be local to the block only, that cannot be accessed by any other function. The 20 value is given to the I in that block only. This is the scoping rule of the function. Then there is a calling convention. The calling convention indicates the order in which arguments are passed to the function when a function call is encountered. So whenever a function call is encountered, that will be used by the function. This indicates the order in which arguments are passed to a function when a function is encountered. That is, a calling function is encountered, or calling function is a criteria when it is used whenever an argument are passed to a function when a function call is encountered. There are two possibilities. Argument might be passed from the left to the right or right to the left. So argument must be passed or might be passed from the left to the right, or it may be right to the left. C language follows the second order. What is the rule that it is follows? That argument must be passed from the right to the left. Consider the following function call. This is the function call. There are four arguments. There are four variables that is used. That is A, B, C, D. These are the arguments. In this call, it does not matter whether the arguments are passed from left to the right or right to the left. However, in some function, the order of passing is become passing the arguments becomes an important consideration. That is, it is also important consideration that passing the argument becomes a important consideration. That is, int a equals to 1. This is the example. Then print the values, that is a plus plus a plus plus. That is the best example for defining whether the argument must be passed from the right to the left or the left to the right. So C follows the second order. What is the second order? That it follows from the right to the left. It appears that this printer would print 1, 2, 3. This, however, is not the case. It outputs at the 3, 3, 1 because it follows the convention from right to left. So if I use right, this will be a plus plus, that is a 3. Why it is 3? Because it becomes, first of all, it becomes it is 1 plus plus 1 means again 2. This is the 2 plus 1, that is a 3. This is plus plus a, this is a plus plus. In this the output is 2, here the output is 3. So whenever we use this one, that is a 3, and then again plus plus a. So first of all the increment will be taken, that is 2. Here 2 will be available, that is 3. So this is 3, 3, 1. That is a calling convention. That is, firstly 1 is passed through the extension a plus plus. Then a is encountered or incremented to 2. So a plus plus means 2. Then the result of plus plus a is passed. That is, a is incremented to the 3 and then passed. Finally, the latest value of a is 3. That is the final value. So in left to right, right to left, this is 1, 3, 3 that get passed. Once printf collects them, it prints in the order in which they are used in the or in which they are printed. This is a dicey condition. That is, whenever we use the get ch a, it will print the values, or it is using the three standard library function. What are the three standard library function? That is a hash include, clear, go to xy and get ch. This helps the compile. So whenever we call the library function, we must write their prototype before making the call. This helps the compiler in checking whether the value being passed and returned as per the prototype declaration or not. But since we don't define the library function, we may not know the prototype of the library functions. This is the dicey condition, that we may not include the prototype because this is not declared as a prototype. Now, what are the advanced features of the function? This is the most important part. This says, with the sound basis of preliminaries of the C functions, let us now get into their intricacies. That is, now let us get the detailed explanation of the functions. Following advanced topics will be considered here. These are the following advanced topics. What are the topics? First of all, function declaration, how function will be declared and their prototype. Then calling function by value or by reference. Then recursion. So these are the three features that is used for the function. One is function declaration, how function will be declared along with their prototype. How calling function will be used, that is calling the function by values or by reference, and then recursion. Then now let us understand these features one by one. That is function declaration and the prototype. This is any C function, that is any C function by default returns an integer value. That is any C function returns an integer value, that is a by default version. More specifically, whenever a call is made to a function, the compiler assumes that this function would return a value of the type int. That is by default the function returns the integer value. When nothing is given, so always returns the integer value. If we desire that a function should return a value other than a int, then it is necessary to explicitly mention so in the calling function as well in the called function. Suppose we want to find out the square of a function of square of a number using a function. That is, or this will be done by using a simple program. This is the simple program for finding the square. First of all, main function will be used. Then two variables are used, that is a float type, that is a and b. Then printf any number, that is printf enter any number, that uses the scanf, and that will be stored in the a. This is %f. Why %f? Because it is using the float number, that is percentage a, ampersand a, not percentage f. Then uses the function. What is the function name? That is square. What is the argument? That is a, and that the function output will be stored in the b variable, that is in b. Then printf a and b, that is print all the values, that is the a and the b. Now whenever this function will be called, whenever this function will be used, this passes the cursor to this place. Now the function name is same, this is of the float type, but the argument, this is the actual argument, that is a, this is the formal argument, that is x. Now the formal argument becomes x, and the variable that is declared is the float y, that is the variable that is declared, that is of y. Now uses the y to get the output. What is the output? X into x. Why? Because we are trying to find the square of a number, and the square is multiplied by itself. This is x into x, that is stored in the y, and then return the y. Whenever this return will be executed, this places the cursor to this one, that is this one. That output will be stored in the b, and then a and the b will be printed. Here are the three sample runs. Enter any number, for example 3. The square of 3 is 9. So if user enter number, this will be encountered, that is 3. 3 will be stored in the memory. Then uses this one, 3. This is again 3. Then 3 into 3, that will be stored, that is 3 into 3 is 9. The 9 will be returned to this one, that will be stored in the b, and then this will be used, that is printf a b, that is the 3 and the 9. Then uses enter any number, that is 1.5, that is a float. The square of the float is, or square of the 1.5 is 2.000, because it is, why it is using 0.000, because this variable, that is b variable, is of float type. Then next run is your enter any number, that is 2.5, again 2.5 into 2.5, that is a 6.000. The first of these answers is correct, but the square of 1.5 is not definitely not 2, that is not 2, this is not 2. Neither a 6 is a square of 2.5. This happened because any C function by default always return an integer value. So it returns an integer value by default. So this also gives the garbage value. This is the next example that you have to study by your own, that is using the float square. In this we are not using any, we are not declare any return type. That's why it is using the garbage value. But in this example, we are using the float type. That is a we specify the return type, that is a float, that does not give any error, or that does not give any garbage value. So the same function will use, that is float square float. This the function is also declared, that is a float square float. Then there is a float AB, that is two variable are declared, that is a float type. Then printf, that is uses the printf that enter any number, uses the scanf, print in the or stored in the memory. Then uses b equals to square b, that is the output of the function is stored in the variable b. Then printf square of percentage f, that is a is percentage f, that is b. Then uses float square, this is the function name that has a return type float. Then float x, that is the float x that is used. Then float y, the variable that is used is the float y. Then y equals to x into x, that is the y has a variable that stores the output as a x into x. Then there is a return y. Why there is a return y? Because it returns the output as a multiplication, that is return y. So this is the output, this is the number, that is 1.5, this is the output, that is 2.25, 2.5, what is the output? 6.25000. Now the expected answer is 2.5, 2.25 and the 6.25 are octave. Note that the function square must be declared in the main function as this one, that is the square function must be declared, that is before using the function, that is the square function, first of all declare, that is declare the argument type as well as declare the return type. So this will be declared at least first of all in the main function, that is float and this float. Like this one. This statement is often called the prototype declaration of the square function. So this is the prototype declaration. What is the prototype declaration? That includes the return type, that includes the arguments. That is a prototype declaration. What it means is square function is a function that receives a float and returns a float. That is, receives a float means that has an argument that is a float type, that has a return type that is also float type. We have done this, the prototype declaration, in main function. So we have done this in the main function only because we have called it from the main function. There is a possibility that we may call square from several other function other than the main function. Does it mean that we would need prototype declaration of square function in all these functions? Now in such a case, we will make a copy only one declaration outside all the function at the beginning of the program. In this practice, you may seldom be required to return a value other than an int, but just in case you are required to employ the above method. This is made possible by using the keyword that is void. This is the example, that is use the void keyword instead of the float or the integer. Now next is your call by value and the call by reference. So there are two concepts. One is call by value, one is call by reference, and this is one of the important concepts. By now we are well familiar with how to call the function, but if you observe carefully, when we call a function and pass something to it, we have always passed the value of variable to the call function. That is, the actual argument are the different and the formal argument are the different. So there are two types of arguments. One is actual, one is formal. And both the values are of different type. Such functions are known as the call by value. So whenever we use the different arguments, that is different actual argument and different formal argument, that is known as the call by value. By this, what we mean is, on calling a function, we are passing the values of variable to it. The example of call by value are shown below. This is the example that is shown below. This is the example that we have discussed. We have learned that variable are stored somewhere in the memory. So instead of passing the value of a variable, we are not pass the location number. So can we not pass the location number, address of the variable to a function? If we are able to do this, that will become a call by reference. So in simple terms, when we pass the value from the actual argument, that is from the calling function to the called function, that is known as the call by value. And whenever we pass the address from the calling function to the called function, that is known as call by reference. So there are two concepts. I'm repeating again. There are two concepts. One is call by value and one is call by reference. So whenever we are passing the values from calling function to the called function, that is known as call by value. And whenever we pass the addresses from the calling function to the called function, that is known as call by reference. So there are two concepts, call by value and call by reference. This feature of C function needs at least an elementary knowledge of a concept known as the pointers. This gives a concept that is known as the pointers, that I'm not going to start in the today's class, because today the functions is over, and functions and pointer, if I'm starting in the same class, that will be so confusing for you. So it's better to revise what we have done and then stop the lecture for today, and tomorrow with the fresh mind we'll be starting with the new concept, that is a pointer. So if I compile what is call by value and call by reference, in call by value the actual and the formal arguments are different, right? And in call by reference the formal and the actual arguments are same. That is, whatever we pass from the calling function, the same will be applied to the called function. The next difference is that if we make any changes in the called function, that is in the definition, if we make any changes, that would be reflected in the calling function whenever we use the call by reference. So whenever we use call by reference, any change in the called function might be or must be reflected in the calling function, but the same reverse cannot apply. So whenever we are performing any operation with the formal argument, that changes will not be applied to the actual argument when we are using call by value function. So these are the two categories that we'll be using, that is call by value and call by reference. So that's all for today's session. Now if you have any doubts, then please clear the doubts and I will answer you. And if from the tomorrow's class I will be starting the next concept, that is a pointers concept. But before finishing the class, let's take a quick review what we have covered in the today's class. We have started with the functions in the last class, that what is a function, why we are using the functions. Now let us summarize what we have learned about the functions. We have discussed that is C program is a collection of one or more program functions, or C program is a collection of one or more functions. That is, whenever we use the C program, it is a collection of more than one programs. Any function or function that get called that is, a function gets called when the function name is followed by a semicolon. That is, whenever we are able to, or whenever we use the semicolon, that means a calling function. That is, a function name is called or function name is used, that is a calling function. This is a calling function. The definition is in the next part. A function is defined when a function name is followed by a pair of braces. So these are the various types or various categories that we have discussed, various points that we have discussed about the functions. Then you have discussed why we are using the function, that what is the benefit of using the function, that is why writing separate functions at all. First of all, it it saves our time, it avoids the rewriting the same code again and again. Also it becomes easier, or whatever what we are doing, it keeps track of that. Then next, passing values between function, that is how to pass the values between the function, that is either uses the actual argument and either uses the formal arguments. There are a number of things that we note about the program. These are the things that we have discussed in the program. Then we have discussed about the scoping rule. What is the scoping rule of the function? What is the scope rule? That is in inner block. It is defined that it is up to the that block only. That is the scoping rule. Then we have discussed about the calling convention. How a calling convention will be done. That argument must be passed from the right to the left. That is the argument passing. Then we have discussed about the dicey situation also, issue also. Then we also discuss about the advanced feature of the function. That is, what are the advanced feature of the function? That is function declaration, prototype, calling function, that is call by value and call by reference, and there is a recursion function that will be discussed in the last of the chapter, either in the tomorrow's class or day after tomorrow's class. Then these are the advanced feature. Today we have discussed about the prototype, function declaration, that is by default it has an integer value, but we can specify, and if we do not specify any type, then it can assume the void value. This is the example that we have discussed. Then we have discussed about the call by value and the call by reference. That is, whenever we are passing the values from the actual argument to the formal argument, that does not impact, that is, there is no relationship between actual argument and the formal argument. But if we are passing the references, that is address, then any change that is made in the formal argument might be reflected or must be reflected to the actual argument. So these are the concepts that we have discussed in the today's class. So that's all for today's session. Thank you so much everyone. In the tomorrow's class, I will be discussing your next topic, that is a pointer. Okay, thanks a lot. Now class is over. One point I want to discuss, there are some conflict in the minds of the student that I am showing you the older version of the PDF, that is a C programming. That is true, I agree with you, but look at the new version. What is the change between the old and the new version? In new version, the language become complicated, the topics become complicated. So I am benefiting to you, I am not against for you, I am in favor of you. And if you think I am against with you, then it's okay, but I am in favor of you.